All right, so this section is about income inequality. The main things that I want you to take away are the tools of calculating income quintiles, understanding the Lorenz curve, and understanding the Gini coefficient. And then I also want you to learn the general trends in income inequality, both over time in the U.S. and across the world. And finally, we're going to learn some about the poverty line and how to calculate the poverty line. Once again, here are some announcements. I went over these Wednesday, but just so you don't forget, we've got a review session on Monday, office hours as usual, and an exam next Wednesday. I like this picture because it puts the idea of income inequality into more concrete terms. So oftentimes we think about income in terms of dollars. Well, in economics, we like to also think about relative prices. And really, at the end of the day, the important thing is how you can turn that income into stuff that you need to live. So a gallon of milk is a nice, very basic measurement. And here we look at how long it takes for each person to, in 3 different types of positions, to work in order to earn enough money to buy a gallon of milk. So minimum wage has to work a half an hour. The median wage earner, meaning that 50% are lower, 50% are higher, has to work 13 minutes. And the CEO guy, those at the top of the income distribution, have to work 0.01 seconds. So there's a pretty big disparity there, and I think that this puts it in a nice perspective. So, like I said, we're going to look at how we measure income inequality with the Gini coefficient and Lorenz curves, and then we're going to look at trends over time globally, and then we're going to talk about how do we measure poverty. So first, let's start with quintiles. Quintiles are a population segment that contains exactly 20% of the population. So this is basically you could do quartiles, you could do deciles, but quintiles are used most frequently just because it's a standardized method that's easily digestible, and so it's how we tend to look at the income distribution. So here's an example of quintiles from recent data. I believe this is either 2011 data, 2011 or 2010. And it just looks at your basic quintiles. You got your lowest fifth, second fifth, fourth, and highest fifth. Both the percent of household income that each quintile gets, the cumulative percentage, and the mean income for that quintile. So we're going to go into this in more detail when we look at building our Lorenz curve. So with the quintiles, we do kind of overlook some interesting trends that continue once you start narrowing it in even further on the top quintile. So if you look at the bottom 90%, the average income is is almost $30,000. And then if you look at the top 10%, the top 10% is about 161,000. But if you look at even more narrowly, look at the top 1%, the average income is around $1 million. So the difference between 160,000, which would be usually considered an upper middle income, and $1 million a year, you already have some major differences just in that top 10%. And then it gets even more dramatic as you keep going. So within that top 1%, if you take the top 10% of that, the 0.1%, you're looking at $3 million. And if you look at the top 0.01%, you've got $24 million a year, which is huge by any standard. And this is the circle that would be illustrating these various sizes of income to really get a handle on what we're really talking about. So interesting stuff. So the income inequality continues to become more disparate as we reach as we divide up that top quintile into smaller pieces. So this is an interesting way to think about income inequality. We talk a lot about an economic pie in economics and making the pie bigger. Here's a more literal interpretation of that. So each one of these colors in these pies represents a quintile of the population. So in this case here, each quintile has exactly 20% of the pie. So we're looking at total equality here. And in this pie, we get a little bit more disparate, where that top quintile gets 36%, the bottom quintile gets 11%. And then over here on the left, we've got the top quintile has 84% of the wealth, and the bottom quintile gets 0.01%. So now so here's, these pie charts represent, there's a mistake in this description. The reason why this is different is that these pies represent the wealth of different countries and how the wealth is divided up. Whereas earlier we were looking at the income in quintiles. So this pie here is Freedonia. This is just a hypothetical, perfectly equal world. And the other two, one's going to represent Sweden, and one's going to represent the U.S. Any guesses of which is which? If you've ever been to Sweden, you'd probably guess that this is Sweden and this is the U.S. Oh, look, we're right. So, United States, when you look at the wealth distribution among different quintiles, you look at an even stronger disparity. And you look at, the bottom 40%, or even the bottom 60% has less than 5% of the total wealth. So it's pretty interesting when you think about how the impacts on what we think of as the lower as the middle class. I'm not quite sure, what exactly that means when we're looking at numbers that they're so disparate. So here's another fun way of thinking about the wealth. I told you there would be cats. So here we go. We look at, here's the fat cat over here, richest. And this is, each cat is 12% of the population. So we're not looking at quintiles anymore. We're looking at less than quintiles, 12%. So here's the richest. They get a big hunk of the pie. The poor little skinny cats over here get a tiny slice. Here's the middle class. So you've got 4 cats in terms of population are sharing this one pie. And here you've got the upper middle class, which is 12% of the population gets that slice of pie. So between the upper middle class and the middle class, you're seeing some disparity where you've got 4 times as many people sharing the same size pizza as just the upper middle class. And then of course the richest versus the poor is not even comparable. So here's an interesting study that was done by Michael Norton and Dan Ariely. And so they asked 5,000 Americans how they thought wealth was distributed in the U.S. And so here, the second line is what they estimated would be the wealth distribution after they learned what we meant by quintiles. So people chose a distribution that they thought was actually representative of the current state in the U.S. And then they said also, what would they like for the distribution to be? Interestingly enough, this looks a lot like Sweden. This is the 11% here, and this is looks like about 30% for the top group. So of these 5,000 Americans, they don't think that we should have complete equality, not like a communist or like an idealized communist situation, but more equality than we currently have. But even more interestingly, what they think the inequality is, which is more than they would like it to be, is way more equally distributed than the actual distribution of wealth. So I thought that was a really powerful study with some interesting implications. Here's just another way of looking at the wealth distribution. Let's see. So this is like the top, where each person represents a given amount of the population. I think this is the top 1% has 99% of the wealth, whereas the bottom 80%. Okay, so now let's bring this into an actual tool that we can measure, and of course we're going to find another way to bring in another graph. So thus we introduced the Lorenz curve. The Lorenz curve and the Gini coefficient are tightly entwined. But first let's point out a couple of features here. The Lorenz curve has the population fraction from 0 to 1 on the x-axis, and the fraction of all income on the y-axis. And the Lorenz curve ends up, if you had a perfectly egalitarian society, you'd be at the 45-degree line. So 5% of the population has 5% of the wealth, 50% has 50% of the wealth, etc., etc. You end up with this 50% line. And then as things become more unequal, you go further away from that 45-degree line and end up with more of the wealth is accumulated in a smaller number of hands. So here you can see that about 80% of the population has about 20% of the wealth in this example, and then the rest of the wealth is here. So remember, percentages of population on the x-axis and income on the y-axis. So then we have the Gini coefficient, which is a single number that builds from this graph, but kind of boils down the graph into a single number. So it's always between 0 and 1. 0 is complete income equality. Everyone has exactly the same. That corresponds with this 45-degree line in the Lorenz curve. And 1 is complete income inequality. Basically, one guy owns everything, and everyone else has nothing. So here, the Gini coefficient is calculated as G is the Gini coefficient, A is the area between this perfect egalitarian line and the actual Lorenz curve. B is the area between the actual Lorenz curve and the axes, or also the perfect totalitarian line. And so you take the area of A divided by the combined areas of A and B to get the Gini coefficient. So first, now let's do an example. We're going to use our current numbers from the U.S. population. So the easiest question is to start with: what percent of total income does 0% of the population receive? Well, shockingly, it's 0%. So you always start the Lorenz curve with this bottom left corner axes. Then next we'll just do this in quintiles. What percentage of total income does 20% of the population receive? Well, let's look back to our graph. Okay, so the lowest fifth gets 3.3% of the income. Okay, so we'll put our next dot right there at 3.3%. So when we look at the next dot that we're going to place, we want to look at the question of how much income does the bottom 40% of the population have. And so you might immediately jump and say, oh, well, the second quartile has 8.5%. But you need to think about the cumulative income. So you need to use the cumulative income to think about the bottom 40%. because together the bottom 40% is the lowest two quartiles. So together they have 11.8%. So then we add the dot here at 40%. The bottom 40% of the population has 11.8% of the total income. Then we look at the bottom 60%, and once again, we're going to look at cumulatively how much income does the bottom 60% receive. And we have the number of 26.4, where that next quartile adds another 14.6% on top of our 11.8%. So here we graph our, at 60% of the population, we have 26.4% of the income. And next we have the poorest 80% has 49.8% of the income. The next quintile adds another 23.4%. So here we have the percent of total national income that the poorest 80% receives. Finally, what percent of the income does the poorest 100% of the population receive? Well, we're always at 100% of the population, we're going to have 100% of the total income. So we always have our end point at that top right corner, just as we always have our starting point at the bottom left corner. Now we can just connect the dots, and we have our Lorenz curve. And so this traces out, as we increase the level of the population, how much does the total income, percent of total income increase. Looks like this slide got a little bit messed up, but this states that the Gini coefficient, as we said before, is equal to the area of A, so here's A, this area right here, divided by this total area, so the area of A plus the area of B. And, you know, we could estimate this specifically, and we could go through and say, well, here's a triangle, here's another quadrangle, and continue to break this up geometrically. Or we could estimate a line for this. In general, if it's super complicated, you'll probably be given the A and B and asked to calculate, or something along those lines. Okay, this slide should not be in here. Okay, so here's a fun map. You can find your home county and look to see what the Gini index is for that county. Now, Gini index and Gini coefficient are interchangeable. It means the same thing. So we have this, each of the colors represents a different Gini coefficient. And remember, 0 was going to be perfectly egalitarian, whereas 1 is perfectly totalitarian. So moving up from 0 to 1, the darker blue you get, the more unequal the income distribution is in that area. So right now here in Massachusetts, we're living in Boston, looks like we've got some pretty dark blue. We're either, looks like we're in the darkest range of the most unequal income distribution. Looks like Nevada, these parts of Nevada that seem to have probably not a lot of people living out there, in Utah, are more equal. And here's my hometown over here. Looks like where I grew up was a little bit more equal than where I went to college. So that's interesting stuff. So you can see there's it varies a lot throughout the country. So interestingly, this looks like the South, big trends. You could say the South looks like it has higher levels of income inequality. Through the Midwest, we have more income equality. And up in the Northeast, maybe somewhere in between. And out West, also somewhere in between. Okay, so despite the pixelation here, this shows the Gini coefficient over time. And you can see that it started off as kind of moving around a little bit before it evened out. And this spike here coincides with the um, I believe that's coinciding with the Great Depression and the end of the stock market boom in the 20s. And then we have this big drop throughout the Great Depression, and we end up with a relatively low level of income inequality throughout the 40s and 50s, 60s and 70s. And then we start seeing this steady rise from the 70s on upward, with a big jump right here. Now, you could look at different political reasons why there's these various jumps. I looked to both recessions and also changes in policy. This area here corresponds to the Reagan-Bush years. Like I said, this corresponds to the Great Depression, and this is kind of the time of economic prosperity where we expanded the middle class, and we were expanding the middle class and had the baby boom generation and everything. So the interesting question to think about is what is driving the income inequality that we've seen over the past over the past 30 years, over my lifetime. We can definitely look at differences in tax policies. You can look at differences in education, and increasing technology that rewards high levels of education much more than it does lower education. There's a lot of different possibilities that we can think through, and it's certainly a question that is worth asking. But first, let's look at income inequality around the world. So here, once again, you notice the Gini coefficients ranging from, well, the full range is from 0 to 1. So your most equal countries, it looks like we have a clear winner here, and that's Sweden. Sweden is the most equal country that we have in the world, according to this picture. The U.S. is in purple, which is on par with Argentina and China, Madagascar, and a lot of Latin America is a little bit more unequal. Canada, definitely more equal, and most of Europe is more equal. So, interesting trends you can see there, and think about what is driving them, and how different levels of development are going to lead to different levels of equality combined with the different policies. So here, the U.S. is highly developed, and so is Europe. Yet we see very different levels of income inequality. So this might be policy driven rather than something that you could say is just based on certain levels of development. So here we look at income before and after taxes. Now, the tax system with our progressive income tax system is going to change the percent of income slightly. So you notice that in the lowest fifth, they go from making 3.26% to 3.31%. So they gain 0.05%. It's not nothing. And the second fifth also gains, because they gain 0.6%. And then the middle fifth loses a little bit. Fourth fifth loses some as well, but 0.5%. And then the highest fifth goes from 51.84 down to 49.46, so losing a little bit more than 1%. So that evens out. Taxes even out income disparities a little bit, but kind of on the whole scale of things, aren't enormous differences in magnitude. So now let's take a look at how we measure poverty. So this is based on two calculations that were made in the 1960s. So first we noticed that a typical family spends about a third of its income on food. So then we thought, if we calculate how much it costs to have a nutritionally adequate but not luxurious diet for different family sizes, then if we multiply that cost of food for each family size times 3, then we're going to get the poverty line. Not the poverty time, but the poverty line. And so basically it's saying, trying to adjust for how much it costs to feed your family, and then making that 1/3 of your total income. So we adjust this for changes in consumer prices over time. Clearly it's going to be increasing over time. So for one person, the poverty line is considered to be about $10,500. For a family of 4, it's $21,000. For a family of 8, $35,000, or about $36,000. That kind of just gives you an idea of the levels. So then you can look at the number of people in poverty over time. So here in the first graph we have numbers in millions, and then in the second we have the percent. So the percentages have varied over time. We have pretty high levels of poverty starting in the 50s, the late 50s, where we're up around 22-23%. And then we put in some, this kind of spurred the calculation of the poverty rate, and also spurred a number of programs to help reduce poverty levels in the late 50s and early 60s. So the poverty level responded by dropping significantly, brought down 10% to a range of about 12 to 13% through the 70s. Then it goes up a little bit, and then kind of bounces in between 10 and 15% for most of the rest of the century. And you notice that each of these blue lines is a recession. So notice how during a recession we always see these upticks in poverty. And notice how oftentimes, like here, you've got this recession, but then the poverty rate continues to rise. Here you see the same thing. Recession, poverty rate continues to rise. Recession, poverty continues to rise. And then it takes quite a while before it starts going down. So it eventually does, in all these cases, it eventually does go back down, but it's a delayed reaction from the recession. I think we definitely see that today as we're recovering from the Great Recession, where the poverty, we can look in terms of the actual poverty rate. You can also look at how much people are signing up for things like food stamps. We definitely see a bigger impact on the poor that's more lasting, whereas those of higher income tend to be recovering much more rapidly. So here we break up the poverty level, or people in poverty, by age. So we look at everyone in blue, and then we have the children in green and seniors in red. So notice, seniors was the biggest. There was a lot of seniors in poverty in the 50s, and that's been declining pretty steadily over time. And same thing with children. We had a lot of children in poverty in the 60s, and it declined some, but has not been as steady in terms of the trend. Now you might be wondering what's caused this decline. Maybe the lobbyists got together, or the elderly got together with the AARP and started effectively lobbying for their rights. But the main thing that's going on, well, you can see in it already started declining, but in 1965 and 66, Medicare and Medicaid was implemented, which helped really further take off a lot of financial burden, especially off of seniors. A lot of children qualify for Medicaid, but that's, there's obviously different things going on here. So there are certainly a number of critiques of the poverty count. So when you're counting who is above and below this line, it doesn't say how far above or below this line is. There's a big difference in someone who is making, the party, the family of four was around 21,000. There's a big difference between a family of four making 20,000 and is considered in poverty, and a family of four making 10,000, and it doesn't account for that. So the poverty gap is another measure that we have for this, and this is basically the amount of money that you would need to bring a person out of the poverty line, and then we can, or bring a person up to the poverty line, so we can add that up over all the people in poverty, and we can get an idea of what is really the gap between our current level of income and the level of income needed to be to have everyone out of poverty. The other thing is that it doesn't account for differences in the cost of living. Imagine the difference of living with a family of four with $21,000 in New York City versus living in rural Kansas. You can buy a house for $20,000 in parts of Kansas, and the rent is extremely low as well. So there's huge differences in the cost of living, and it doesn't account for that. So we're going to be overestimating poverty counts for some areas, but vastly underestimating the poverty count for other areas. It also doesn't account for benefits such as food stamps and health insurance. So people who are receiving food stamps or Medicaid might be above the poverty line with those benefits in place, but would fall below it without. And it also doesn't account for taxes paid. So if you pay taxes, that's not really part of your usable income, but that's not subtracted from the from what the income level you use to determine whether you're in poverty. So the living standards, interesting. Like this is an interesting point. So we measure the poverty line based on income, but living standards don't really depend on income necessarily. They depend more directly on consumption. So some people are going to, imagine the difference between a family who, two different families. They're both, their income puts them below the poverty line. But one family is, has a great deal of savings, and they have a temporary loss in income. And the other family has been in poverty for years and years and has no assets whatsoever. The consumption levels of those two different families are going to be very different. Thus, the living standards are going to be very different. So Amartya Sen, who is an excellent economist here at Harvard, he's a really nice guy. You should try to take a class from him or go talk to him at some point. So he says that that the poverty line should account for differences in income requirements to achieve a basic functioning. So in this sense, like if one person has a serious illness, or if one person is disabled in some way, the amount of money they need to achieve that basic level of functioning is totally different than if someone is able-bodied or doesn't have health expenses to deal with. So let's wrap it up with just a recap here. We've learned different ways to measure income inequality and poverty with the Gini coefficient, Lorenz curve, the poverty line, and the poverty gap. So just global trends. Briefly, we've got the global Gini coefficient is 0.68. So remember that's actually quite high. The highest category was 0.6 and above in the map that we showed of the world. So globally, if we count the whole globe as one population, it even becomes more unequal than looking at the within-country differences. And the U.S. Gini coefficient is about 0.4, which is pretty high for developed countries. And you can see the time trends in income inequality. In the U.S., we've had a big decrease after the Great Depression, but then it's been increasing since the 1970s. And the poverty count was very high in the 60s, and it's been between 11 and 15% since the 1970s. So now I'm going to leave you with a quote and a quiz about this quote. Income inequality can be measured and compared using something called the Gini coefficient, a century-old formula that measures national economies on a scale from 0 to 5, with 5 being the most unequal. And this is from Max Fisher. I found this article in the Atlantic when I was researching for this. And my question is, do Max Fisher and his editors need to retake Ec 10? So think about what is wrong with this quote. I'm sure some of you would be raising your hands right now and saying, well, first of all, the Gini coefficient doesn't go from 0 to 0.5, it goes from 0 to 1. And secondly, 0, I guess he got the direction right. So 0 is the most equal, and 1 is the most unequal. So now you know more than Max Fisher and the editors at Atlantic about at least the Gini coefficient. Feel free to contact me with any questions, and there's certainly tons of interesting things on the internet that you can find with discussions. I'd love to hear some of those things posted on Piazza, or things that we could discuss in office hours. Thank you very much.